How you doing, Professor Swim? My name is Mike Kaira. So with this video portfolio, I know I'm a little bit late, but I'm really excited to show you what I've learned in block 1 out of the 6 lessons, and really just touch base on where I had issues at first, where I didn't, and what helped me to really understand the concepts of each lesson. So let's get it. All right, so first we'll start off with trigonometric substitution, which was in lesson 7.4 in the Hawks Learning Journal. So the question I had, the problem I had issues with was the integration of 5x square root of 36 minus x squared dx. Now the goal is to choose the substitutions that are helpful in evaluating the integral, but we don't want to evaluate. So first things first, that I typically challenge myself to do when I do these problems was, write down a methodical procedure to where I can find out what needs to be done exactly, and like really rule out anything extra or anything like that. So, and that's one thing that really helped me going forward with doing my problems, writing things out in steps rather than just cluttering everything up and giving myself an aneurysm. So we're just gonna go ahead and get right into it. So first we're gonna determine the integrating form for 5x square root of 36 minus x squared. So the integrating that I chose was square root a squared minus x squared, which in substitution equals x equals a sine theta, which is on the interval of negative pi divided by 2, which is less than or equal to theta, which is less than or equal to pi over 2. So then the next step is to figure out what trigonometric substitution we're going to be using. So as you can see, a squared equals 36. So what we do, square both sides, and we get a equals 6. And we can plug that into our formula right here, and we get x equals 6 sine theta. So we have that. Now, part of the integrating is a second degree polynomial, and the rest is a first degree polynomial. So now we have to figure out what substitution we can use to simplify that integrating. And I didn't really understand this part, not too much, but once I read it, I kind of like had a feeling. But so the second degree polynomial that I decided to use was theta equals square root 36 minus x squared. So now that we've done the problem and figured out which substitutions we're using, the solutions to this problem would be x equals sine theta and theta equals square root 36 minus x squared. And those are the two substitutions that we're going to be using to help evaluate the integration of 5x square root 36 minus x squared dx. Thank you. So for our next problem, our next objective, we're going to be using integrations by part to figure out what is the integration of x squared logarithm sine x dx. And we'll figure this out, and then we'll use c for the constant integration. So what we'll do first is that first and foremost, the integration by parts formula is the integration of u dv equals uv minus the integration of v du. So that's our formula. So what I like to do is I like to first start off with picking out what is important, as in like what we need for these variables to equal, and then plug them back in, which is hypothetically what we're going to be doing. And then we're going to simplify. So first and foremost, we're going to let u equal logarithm sine x and let v equal x to the third over 3. Now, the way we got x to the third over 3, that's the antiderivative of x squared. And we used u as our substitution. Now, the antiderivative of logarithm sine x is 1 over x dx. And the derivative of x3 over x to the cubic power over 3 is x squared dx. So now that we got all of our variables and values in place, now all we have to do next is plug it in. So we plug in our values, and this is what we get. But this is a little bit too convoluted, and it just needs to be simplified even further. It's very complex and just needs to be simplified even further, so we can just go ahead and clean it up. So what we can do is we can bring these two and make logarithm x a constant to x cubed. Okay, so now we can simplify this part of the formula by saying as x, we can cross out 1x for each, and we get x squared. So then we'll get x squared over 3, and we can bring out the constant 1 over third and have 1 over third before the integration sign and have x squared as the remainder. And then we'll keep simplifying. Where we'll eventually get x cubed logarithm sine x divided by 3 minus x cubed over 9 plus c. So our last objective, I started from what I thought was pretty difficult to was a little bit minor, but not gonna lie to you, antiderivatives were pretty difficult. Just memorizing all the really just all the antiderivatives and derivatives, just make sure to memorize literally the back of my hand. So I feel like that was pretty difficult, and where I struggled a lot at first when I came into Calculus 2. So this is gonna be a little fairly quick and easy, but it was just one of the questions I feel like it was really just really figuring out what to do, honestly. So let's jump right into it. So what we're going to do is try to find the antiderivative of f of x equals 8x minus 7. And we'll use c for the arbitrary constant, just like we did before. All right, so like I said, sorry about that. I had to do a short intermission because I had to answer a phone call. So we'll just pick up where we left off. So like I said, we'll use c for the arbitrary constant. Now, first we need to determine the general antiderivative for f of x by anti-differentiating f of x equals 8x minus 7. That's another word I struggled with, anti-differentiating. I can't even say it right. So yeah, so we're gonna do that term by term for 8x minus 7. When we do that, we get the first term, 8 over 2 equals x squared for 8x, and then we get negative 7 equals negative 7x. Now, an antiderivative of a function f of x is any function f of x such that f prime x equals f of x, and the general antiderivative of x to the r power is 1 over r plus 1 times x to the r plus 1 plus c, where c is an arbitrary constant. So we get f of x equals 8 over 2 x squared minus 7x when we bring those together plus c. Now we're not done yet. We can still simplify, and then we can get some a much less complex algorithm, or a much complex equation. So if we divide 8 over 2, we get 4, and then we bring the x squared over. Minus 7x, we keep that the same, plus c. We get 4x squared minus 7x plus c as our final answer.